In this video, we are going to speak about some measures that let us to know what is the importance of the nodes in a network. And these measures that we are going to speak about are page rank, the results of the algorithm of hubs and authorities, and different measures that we can speak up for given the centrality of a node. So besides of the degrees, there are different metrics that can indicate the relative importance of a node in a network, and are the first two that we have indicated, page rank and the results of hubs and authorities, and some measures of centrality such as betweenness or proximity centrality, which is also called closeness centrality. The first one that we outlined here is the page rank, and the page rank it was the base of the algorithm of Google in their first version, and the thing is that it tries to measure what is the importance of a node in the following way. It's considered that the page rank is the importance of a given node, and this can be computed as the solution of a linear system of equations where we have that the nodes are the page rank of the nodes, and what we have is that each page rank can be computed as a factor 1 minus lambda, where lambda is a value that is given the importance of the existing connection, so lambda is usually close to 1. And later what we have is that a sum of the page ranks divided by their outgoing degree. So the thing is that the page rank of a node is like an average of the page rank of the adjacent nodes, right? But each one of their adjacent nodes has their page rank divided by their outgoing degree. So somehow the importance of the page rank of a node is distributed among their adjacent nodes. So the thing is that for computing there is in statistics we can use the following measures: the probability P, which is also as the factor lambda that we have indicated, that can be considered close to 1. In general, it's first considered as 0.85, and the factor epsilon is a numerical factor that is used for the convergence of the algorithm for computing the page rank. And the result here that you can see is that this is the score. Usually the page rank are values that are close to 0, but a small difference in the page rank is quite relevant for indicating which nodes are more important than the others. Here on the x-axis, the score is indicating what is the page rank of a node. Recall that, as in the previous measures, whenever we are computing measures like the degree, the clusters, the modularity class, this appears in the data lab table. And here what you can see is that if you order for the page rank, as it is here the last column, it almost agrees with the result, or that if we have ordered by the degrees that you can see in the column in the middle. But the thing is that the page rank is trying into account not just that you have many connections, but connections with the relevant nodes of the network. Again, what we can try to do is to color the graph by doing a ranking in terms of the page rank, or also to use the size as between two different sizes for computing the page rank. The thing is here we can mix the measure of the degrees and the page rank, one for the color, another for the size, and this can help us for having nice representations and more complete representations of the network. The second measure that we have indicated is the result of the HITS algorithm, which is hypertext induced topic selection, and it has two parts: authorities and hubs. This algorithm was based in the idea that the authorities in a network are the pages that have the relevant information, and hubs are pages that contain many connections and make it easy to pass from one website to another website. So the thing is that if we have good hubs are expected to connect with relevant authorities, and authorities stand out when they are connected with major hubs. This first idea of hubs and authorities was given two measures for each node. So on the one hand, we have the hubs distribution for each node and also the authority distribution. At first sight, you can see that there's quite a similar representation of the values, so it seems that they are not really different. And in fact is that you obtain two measures, and in most of the cases they're almost equal in this network, which is not necessarily the case, as we have seen. The authority and hubs are different measures. The difference between hits result and page rank are the following. Hits was also an algorithm designed with the birth of the web browsers, and it was depending on each query term, but page ranking no. The other thing is that hits was launched each time that the query was made. The good thing about PageRank it was computed periodically, but once it is computed, it lasts for some time. Also, hits calculated two scores per document, authority measure and hub measure, and PageRank only one. And hits runs on a subset and PageRank on the entire network. For all these reasons, PageRank was more relevant, more prevalent, and in the end, the success of Google was due in part to that the idea was more clearer and more simple the result to order web pages. Other measures that we have seen at the beginning were betweenness and closeness centrality, which are related to indicate how in the middle it's a node in the following sense. So when we're computing the betweenness centrality, what we are measuring is how many times a node appears in the shortest path between any pair of nodes, right? So, but if two nodes, there is what we have to take into account is that there are several shortest paths between two nodes. The thing is that the nodes in each path has it's counted half of times here. So the number of the importance through different shortest paths is divided between each of them. And also another measure is the closeness centrality. It's computed not by how many times appear the nodes on the shortest path, but computing the inverse of the average of the distances from a given node from node vi to node bj. Also, these distances, we can compute the inverse of these distances, and we will have the harmonic closest centrality. So here what we can have is the different representations here where betweenness and closeness centrality distribution, and it's relevant also if you go to the data lab table and try to compare which are the measures. Closeness and harmonic closest centralities are measures that are ranked between 0 and 1, so we can appreciate small differences. But if you see betweenness centrality, the range is very high because it depends on the square of the number of nodes, which is the maximum, the square of n, well, n times n minus 1 divided by 2 is the maximum number of times that given node can appear in the middle of a shortest path. So different measures for speaking the centrality with several outcomes, but in any case, in the example of the Zacharias Carlton Club network, you can see that nodes 1 and 34 were ranking on the top and at each one of these measures. So it gives you some insight that they are once they are relevant, it's the results may differ but not very much. Okay, with this was all we want to say about the measures of importance in a network. Thank you very much.